All right, guys, thank you for coming in and checking out your homework, see how you did. All right, so this is guided practice, page 260, numbers 1 through 6. Let me give you the answers first. As you can see, the answer for number 1 is 2. The answer for number 2 is 10. The answer for number 3 is 0. And number 4 is 28. Number 5 is 33 feet. And number 6 is 240 feet squared. All right, so let's start with number 1, obviously. By the way, if you got them all right, you can stop right here and just do other things if you need to. Or if you want to see how I did it and compare it to how you did it, that'd be a good idea too. Again, the answer might be only one. There's more than one way to get the answer. Okay, so it doesn't hurt to look at how other people did their work. All right, anyways, let's get to this. 1/8 times 15ths. Estimate each product, use a bar diagram if needed. Okay, before we do anything else, let's see what we're doing here. We have 1/8. It always helps to visualize it first. I know some of you just want to attack the number and get it done quickly. Guys, that's not going to help if you don't understand what's going on. All right, so here's my 1/8. I try to make the pieces as equal as possible. Here's my 1/8, 1 out of 8. So basically, I'm taking bars, cutting them into 8 pieces, and I only want 1. Okay, so for each set of 8, I only want 1. So how many of these little pieces do I have if I had 15 bars to cut up? Okay. Now, since I'm cutting up 15 into 8, I have to think of a compatible number. Why? Because I just want a real quick answer in my head. How many of these little pieces would I have if I have to do this 15 times? Okay, well, let's set it up. I know 15 doesn't work with 8. I can't divide 15 by 8 evenly. I'll get a decimal number or a fraction, sure, but I want a whole number. It's easier that way. Now, I know 16 is a multiple of 8, so I'll try that instead. Okay? And if I do that, I'm going to do the math, and you can probably do it in your head anyways. But if I'm taking 16 and breaking it up into 8 parts, that means I can put 2. Now let me give you some context. If this is $16, that means if I had 8 people, each person would get $2. So the answer is going to be 2. Okay? Well, let's do the work now. 1/8 times, I'm going to change it to 16 just because that's what we decided to work with best over here. To change a whole number into a fraction, you put a 1 under it. Numerator times numerator, 16. Denominator times denominator, 8. And a fraction would show division. So we have, I already did the work, but I'm going to do it again anyways. We have 2. Okay? If on the test you want to do it visually like this, that's fine. You want to do it with the math, that's fine too. Whatever works for you. Okay? But do the work. Try it. Don't just look at it and say, oh, I get it. Do it on a separate sheet of paper without looking at the answer. Okay? All right, now here we go. 2/5 of 26th. All right. So again, let's just pretend that we have 2/5 here. So we're making sets of 5. And I said it before, I'll say it again. Always look at the denominator. I'm making sets of 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Again, I'm trying to make the pieces as equal as possible. Doesn't always work, but that's okay. All right, so 2/5. Out of 5, I only want 2. So for every 5 that I cut, I only want 2 pieces. So I only want maybe this much. Okay, it's like saying, for every pizza you get, I'm going to cut it into 5 slices, and you get 2. Okay, so here's my question. It's going to be kind of gross if you think about it, but let's not go too far. If I were to have 26 pizzas, whole pizzas, and I cut them all into 5 pieces, how many slices would you get if you only get 2 out of those 5? Okay, that's another way to think of it. Okay, now here's the deal. I'm trying to make groups of 5. So I have to divide this into groups of 5. Again, since we're estimating, I want to work with a compatible number. I want to do something I can do easily in my head. 26 doesn't work, but 25 does. Right? And if I do that, I'm just going to go ahead and do it in my head because I think most of you know your time skills by now. 25 into groups of 5. That gives me 5 groups of 5. 5, 10, 15, 20, 25. All right? Now, let's just do the math. Now, what is that? So that's 5 and 5, right? Times 2. What is that? Well, actually, it's just 10, right? There you go. 5, 10, 15, 20, 25. That's just 10. Sorry, I had a momentary lapse. Okay, so here we go. Of means you're going to multiply We decided not to use 26. We're going to use 25 instead. It's more compatible with the 5. You can divide it easily this way. Change the whole number into a fraction by adding 1 under it. Okay. Numerator times numerator, denominator times denominator. All right. 2 times 25 is 50 over 5, which is 5 times 1. And that gives me 10 again. Okay, hope that helps. Number 3. Okay, I have 1/5 times 8/9. Okay, now here's the situation. How is this problem different from the other two that we've done already? We don't have whole numbers anymore. We have two fractions. We want part of a part. Okay, so out of this 1/5, 1, 2, 3, 4, I only want one. I want one part of that fifth. So here's my 1/5. And this 1/5, I only want 8/9 of this. So I don't even want this whole piece. I want a smaller piece than this. Okay? Now, I could do another way of, there is a way to do this to figure out the answer, but right now we're just working on estimating, so I'll just leave it at that. Basically, I just want you to understand that we want a piece of the piece. So something less than 1 times something less than 1, how much do we have? Again, think of it, 1/5. 1/5. We want only even a little part of this. Now again, this is not 8/9. This is not 8/9. It's 8/9. I just wanted to let you know that we only want a piece of this. So let's do some estimating. Since we don't have a whole number, we're going to have to do the whole benchmark fractions. Okay? Here's the deal. You understand the idea of 0. You understand the idea of 1. And in the middle, you have half. You have two pieces. 1, 2. One whole slice or nothing. All right, so let's do this. 1/5. How does this work? Is 1/5 closer to 0, half, or 1? Well, I'll look at the denominator. 1/5, the denominator is 5. Half of 5 would be 2.5. So 2.5 fifths would be half. That's the halfway point. 1/5 is somewhere here. It's only one away from 0. So I'm going to say that 1/5 is close to 0. Okay, but I'll do that later. Just hold on for now. Now here we have 8/9. I'm going to rewrite it in red so you can see something. All right, half of 9 is 4.5 ninths. 4/5 ninths. 4.5. 4 and 5/10 out of 9. All right, now the numerator is really close to the denominator. You almost have the whole thing. Okay, so I'm going to rewrite this. I want you to see something. 1/5 times 8/9. 1/5 is close to 0. 8/9 is closer to 1. What's 0 times 1? Just 1. And there's your answer. Okay? Here's number 4. Be careful. This takes a little bit of thinking. Again, just think it through. Don't jump into it. Don't assume anything. We have 6 2/3 times 4 1/5. Okay. To do this problem, I'm going to rewrite what I wrote in the other problem. Just a little number line from 0 to 1 and half. Are we closer to 0? Are we closer to 1/2? Or are we closer to 1? Just remember that. Okay. I want you to remember something. When we talk about fractions, we're really saying 6 2/3. We're saying the whole and the part times 4 1/5. Again, the whole number is the whole. We have 4 wholes, and the fraction is the part of a whole. There you go. And. Just keep that in mind. So there's a reason I'm saying this. 6 2/3. So in terms of math, it would look like this. 6 2/3 times 4 1/5. And why did I do that? I want you to understand that it's not just 6, if you try and think of 6 and 2/3 together and try and use this, you're going to get confused. Just break it apart. Break it apart into smaller parts that you will get. Understand? Okay? So here's 2/3. I'm going to write this in blue. 2/3. Okay. 2/3 is right here. Half of 3. Again, look at the denominator. What's half of that? Half of the denominator is 1.5. So 1.53. 2/3 would be somewhere here. Now, here's the thing about this fraction. It's actually in the middle of half and 1. But since I'm going to estimate, I'm going to estimate up. Sometimes it's better to have too much than not enough. So here's my 2/3. And for the other fraction, I have 1/5. 1/5. Okay, denominator is 5. Half of 5 is 2.5. So if I had a fraction that would be half of this, that would be half of this, half of 5, would be 2.5, right? So if I were to cut something up into 5 parts, one part, well, there it is, but 2.5 would be right in the middle. 1/5 is somewhere here, and it's actually 1 away from 0, so I'm going to say it's closer to 0, right? And now watch what I'm going to do here. 1/5 is closer to 0. 2/3 is closer to 1. Now again, please, just trust me on this one. If you're estimating, sometimes it's better to have a little too much than not enough, especially if you're building something or you're sewing something, you're making something. It's better to have too much material than not enough, okay? But not too much. You don't want to spend overspend the money. But just keep that in mind. That's what I'm saying. Sometimes it's better to have too much than not enough. But here we go. 6 plus 1 times 4 plus 0. PEMDAS, please excuse my dear Aunt Sally, do parentheses first. Left to right. 6 plus 1 is 7. 4 plus 0 is 4. 7 times 4 is 28. And that's why number 4 is 28. Okay? Now, how can you verify this? Like, well, how do I know that you're right? Okay, for just a moment. If you forget, when you have to multiply fractions, you're like, I don't know what to do. You can always just multiply the whole numbers, just as a quick instant check. You have 6 and 4. 6 times 4 is 24. That means I have 4 groups of 6 or 6 groups of 4. Either way, you're going to have 24. And look at the answer. It's pretty close, so we're pretty on target here, okay? All right, number 5. Again, just step by step, think it through. Don't rush it. I know I'm kind of speaking really fast, or I might make some mistakes with my words. Don't listen so much to what I'm saying. Watch what I'm doing. Try to do both. Listen to me and watch what I'm doing, but mainly see what I'm doing, okay? And if you catch a mistake, please tell me. I always appreciate that, okay? Because I will make mistakes. I'm not perfect. Okay, a border. Next one, number 5 is a word problem. A border is made of 32 2/3 bricks that are 1 1/6 foot long. But how long is the border? All right, again, I'm just going to draw a real simple picture. Here's my wall, which is what a border is. It's a wall that separates, or it could be a fence as well, but it's something that separates 2 areas, 2 places. At least that's what it means to me, a border / wall. Do a different color. All right. So we have a wall. Let's see. It's made out of these bricks. Again, a little brick. Okay. How many of these bricks do we have? Again, I'll write the word brick. Again, if you can imagine a little brick. B-R-I-C-K. All right. We have, how many of these bricks? We have 32 bricks and part of another. Right? But what else do we know? We also know that each of these bricks is 1 1/6 foot long. Okay. So the question is, how long is the border? So you have all these bricks, 32 of them in a row, plus part of another, and they're this long. How long is the border? That's what we're trying to figure out. So the multiplication problem is 32 times, let's see, jumping the gun here, 32 2/3 bricks times 1 1/6 foot long. All right. This is just like the other one. Break it apart. Break it apart. Don't just jump into this and try and figure out the answer. Although, if you want to do a real quick summary, or quick summary, see what I'm saying? Don't listen to what I'm saying. If you want to check your answer, what it will be, if you want to predict what the answer will be before you start, look at the whole numbers. I have 32 and 1. The answer is going to be pretty close. Again, approximately 32 feet. Okay? But don't count on that. Do the work. Seriously, get into the practice doing the work. 32 and 2/3. I'm using a plus sign instead. That's what it means. Times 1 and 1/6. Okay, now just like before, you're going to have to do it real quick. Now, at some point, maybe now, but if not, don't worry. You might be able to do this in your head. If you can't, don't worry. You'll get there. Just practice. That's the only way to get better at this is if you practice. Okay. So 2/3. I'm looking at 2/3. 2/3, the half of the denominator would be 1.5 out of 3. I have 2, and just like the problem we said before, 2/3 is 1 away from the denominator. I'm going to say it's closer to 1. Okay. Now, 1/6. Look at the denominator. Half of 6 is 3. So 3/6 would be a half. But check this out. The numerator is only 1. So 1/6 would be here. It's pretty close to 0. It's actually 1 away from 0. Okay. So this is actually closer to 0. This is closer to 1. 32 plus times 1 plus 33 times 1. 32. Okay. We got the answer. Now again, please remember we are estimating here. It's not going to be the exact same answer. It's not going to be perfect. Okay? That leaves us with number 6. Okay. Number 6. A kitchen measures 24 1/6 foot by 9 2/3 foot. Estimate the area of the kitchen. All right. We have a kitchen that is 24 and 1/6 foot long and 9 2/3 wide. Now to find the area, this looks like a rectangle. Remember, the area is length times width. This would be the length. This would be the width. Okay, wide, width. All right. So we have to multiply both of them. 24 1/6 times 9 2/3. Now, actually, I'm forgetting something very important here. I'm forgetting the unit of measurement. You have to include that. If it gives it to you in the problem, it has to be either in the answer. Okay? Foot by foot, which will mean the answer will be like foot squared, right? Now, here's the deal. Before I do anything else, if I want to do a quick prediction, I'm looking at the whole numbers only. 24 times 9. Well, again, since it's estimate, I'm going to say 10 instead because 24 times 10 is more compatible for me than 24 times 9. So the answer is going to be about 240. About. But let me go ahead and do the math, okay? So you can see. All right, 24 1/6, 24 and 1/6 with just plus times 9 and 2/3. Okay, again, setting up the benchmarks. Now, why do we benchmarks? Because we have fractions times the fractions. We want part of a part, and that just makes it too hard, well, to do in your head, at least for me. So I want to think, is it closer to 0? Is it closer to half? Is it closer to 1? It's just much easier to add halves and 0 and 1s, or even subtract halves and 0s and 1s from each other. Okay, for me. Again, you might be different. I'm just presenting to you a way to do this. All right, 1/6. Okay, look, I'm not going to do the half of the denominator. I can tell. If it's 1 away from 0, I mean, out of 6, I only have 1. That's pretty close to having nothing. I'm going to put 1/6 right here. Just think it out. Think it out. That's all I'm saying. Reason it out. All right, 2/3. We've done this many, many times. By now, you should know at this point 2/3 would be closer to 1. Okay? So, closer to 1, closer to 0. All right, PEMDAS, parentheses first. All right, please excuse my dear Aunt Sally. 24 plus 0 is 20, and we go left to right. 24 plus 0 is just 24. 9 plus 1 is 10. Hey, look at that. I was kind of right anyways. I'm awesome. No, I'm not really. 240. 24 times 10 is just 24 times 1, which is 24. Add the 0. Boom. It's just a shortcut. And that is the guided practice.